Mostly they just hear what I'm saying, but if you shout really loud, they would hear you. Yes.
That's enough.
Okay, so once again, we are looking at piecewise functions, and we said we had a test to determine if something was a function. What was that test?
Vertical line test.
Okay. Vertical line test. So we are going to be looking at that. Okay. What makes something a piecewise function is we take pieces of different functions and we kind of throw them all on the same graph. Okay. But we just take parts of them. So you might see part of a parabola, or you might see part of an absolute value graph, or you might see part of an exponential curve. Okay. So we're just taking a chunk of this one and a chunk of this one and a chunk of this one and mixing them all together. Okay. You will see things like this. This has two pieces to it. Notice that domain part. So the first thing I do is I look at that domain breakdown. Okay. What it's going to do is it's going to take my coordinate plane and it's going to split it into pieces. So we have one chunk where x has to be less than -2. Okay. We have another function that would apply when x is greater than or equal to -2. Okay. So we have a break happening at -2. So I'm going to have you draw a line in. Just make it a light dotted line, but that's going to be our break at -2. Okay. So we're going to have one chunk on the left side and another chunk on the right side. So for the piece here that says x has to be less than -2, is that on the left or right? That's on the left. So on the left, we want this function. Okay, so I'm going to write it up here. Y equals x plus 5. That's the function I want on that side. Okay. The second one applies only when x is greater than or equal to -2. So that would go on the right side. Okay. So what you're going to do is you're going to graph them. Ignore the break for a minute. Okay. Just pretend you're graphing the shape. What are these two shapes? They're just two lines, right? So how do we graph a line that's in y equals mx plus b format? Okay, so we start with the y-intercept, all right, where we're touching the y-axis, and then we use the rise and run to get other points, yes? So if I'm graphing the green one, it says I start at 5. Now, start on the y-axis, not your break line, okay? On the y-axis, we're going to start at 5, okay? And we want a +1 slope. Well, if I start rising and running to the right here, I'm putting dots on the wrong side, right? I want this over here on the left side. So I'm going to go backwards so I can get some points on the left. So down and back, and do enough that you have several points over on the side that it's supposed to be on, okay? Then the next thing we look at is where that line hits the breaking point, okay? So this vertical line was at x equals -2. Where we hit it right here, do we want that to be included? In other words, can we use this function when x is equal to -2? No, it has to be less than -2. So you are going to put an open circle here, and you're going to erase the extra dots that you had. Maybe you're going to erase the extra dots you had over here. Okay, so the result is this part of the line. Okay? Does that make sense? Okay. For the blue one, okay, on the right side, we want the equation y equals -2x minus 1. Okay, so where would we start? At -1 on the y-axis at -1. And we want a -2 slope. So down 2 over 1. Can I go up 2 and back 1? Yes? Up 2, back 1. Now, what happens, and it doesn't always happen, but in this case, the two lines met. Okay? So the green one we had an open circle on, but the blue one is going to fill that in. So it won't look like this is not included because on your paper, everything will be pencil marks, right? Okay, this is a very typical piecewise function. The next question says, is it a function or not? So this is where you check, because the answer to every question, to every problem on here where it says, is it a function, is yes. It should be a function. They're telling me right here it's a function. But you would be surprised how many people graph it incorrectly and then they say, no, it's not a function. It doesn't pass a vertical line test. In other words, maybe somebody put this green line up here instead of where it's supposed to be. Well, now it doesn't pass a vertical line test with the blue and red parts. Okay? So what you want to do is once you've got your graph done, double check. Does it pass a vertical line test? It should. Okay? Does this one pass? Yes. So our answer here is yes. The next type of question they're asking here is to evaluate your function at 3 different values here, at a 3, a -4, and a -2. You have to decide which of the 2 pieces applies for that x value. So when x is 3, is this in the domain of the green function or the blue function? If x is 3 greater than or equal to -2? So it should go in this blue function. Does that make sense? So you're going to put 3 in where x is in the blue one. What do we get? If we check -7, putting an x of 3 in, we should get a y value of -7. So go over here to 3. Are we down here? Did I not go far enough? 1, 2, 3. Down here at -7. Okay, that fits. Which function, the green or blue, do we use if x is -4? Now we need to use the green one. So we put our x in and add 5 to it, and we get a 1. So checking that point. At -4, are we up here at 1? Okay. Talk at your tables. Which function would we use for a -2? -2 is a tricky one, isn't it? Because I see -2's in 2 spots here, right? Those both say a -2, but which one has it equal to -2? The bottom one. So we have to use the bottom one. Does that make sense? Which gets us 3. Okay. The last type of question that you're typically asked for is the range. Range is which variable? That's the y's. So in this case, start at the bottom and work your way up. What y values are being included in these graphs? It doesn't matter which part of the graph. Okay, is it ever used? So down here at the bottom, are these y values being used? Yes, right? Because these lines extend forever. So everything down here is being used. Where's the stopping point? At this big dot, right? Our graph can't go any higher than that. You know these lines aren't going to turn around and go the other direction, right? So what's that maximum value here? 1, 2, 3. So we would say y has to be less than or equal to 3. All right. What shapes will we have on the second one? Still lines? Okay. We will move on to something other than lines very soon. Where's the break going to happen? At 1. We have a break here. So let's draw a little dotted line in there at 1. Which function goes on the left? Okay, the bottom one this time. So y equals 1/2 x minus 3. That's for every value of x that's less than 1. Okay, and then on the right-hand side, we have this, the top equation, 2x plus 1. All right, we'll start with green. We have a y-intercept of -3. We have a slope of 1/2, which means what? Up 1 over 2. Okay, so now we have a problem, right? Because now we're on both sides of the break. Can I go down 1, back 2? Okay, so I can get a few dots back here to get my line drawn. But where am I going to hit at this breaking point? At x equals 1. So this is down 2.5. So from here, I would have a dot halfway through this grid. Yes? Okay. Is it going to be an open or closed dot? Okay, because it's not equal to. We're doing this one, right? So where I would hit that dotted line, I'm going to make an open circle. Let's clean that up so it looks like an open circle. Okay. And then we have to draw in our line on the left side. Correct? Okay. So graphing the blue one, we're going to start at 1. We're going to do a +2 slope. Where are we hitting the break? At 1, 3. Solid or dotted? Okay. So I'm going to get rid of this extra dot over there because it's on the wrong side. And then I can draw in my line. Okay. Does it pass a vertical line test? Yes? Okay. Which function do I use for x being -2? X being -2. Bottom one? Okay. So we've got 1/2 times -2 minus 3, which gets us what? Okay. Which function do I use when x is 6? Okay. And if x is 1, that's where my break is, right? So now I have to pick which equation. Which one am I going to use? The top. Okay. The difference with this piecewise function is that the pieces don't connect. All right? There's a break between the two pieces. And that's fine. But it causes a little bit more work for us when we talk about the range. Okay? Because now we're going to have to define two different sections. Because all of the y values in between these two endpoints don't count, right? We can't use those. So for the green part, I can go to -infinity, right? I'm going to go down forever. My stopping level was here. And we said that was at 2.5, right? -2.5. So I'm going to go from -2.5 down. Can I equal -2.5? No, it's an open dot, right? I can get really close to it, but not equal to it. So I can say that y has to be less than -2.5. Okay. For the blue part, now my graph is going up from this dot, which is at what level? I'm at 3 here. So my y values could be 3 or higher. Yes? So y has to be greater than or equal to 3. Those are the two parts to my range. All right, we're going to skip to number 4. What's different? There's 3 functions instead. Okay. Are they all lines? They are all lines still. Okay. So where are my breaks going to happen? At 0 and 5. Okay. Which function goes on the far left chunk of my graph? The top one? How do I know? Look at your domain. If your x's are less than or equal to 0, which would be everything on the left side here, that's the function you want to use. Okay? For the piece that is between 0 and 5, this vertical chunk here, that uses 2/3 x minus 1. And then on the far right, for all x is greater than 5, I just want a 2. Well, what's y equals 2 going to look like? Just a horizontal line, right? Just says stay at 5 forever. Okay, or sorry, stay at 2 forever. So I'm going to have a horizontal line here at 2. Open or close circle at its endpoint. Do I have an equal sign here? No. So open circle. Okay. Let's do the middle section. That one says we want 2/3 x minus 1. So we're going to start at -1. And we want to go up 2/3. Okay, so we have a problem again, right? Because where we hit this x equals 5 line, it's going to be in between the 2 grid marks. Yes? Let's check where it should actually be. Put a 5 into this function. It's one of the ones we had to do anyway, so we'll do it now. So put a 5 in here. 2/3 times 5 minus 1. What's 2/3 times 5? 10/3. 1 is the same as 3/3. So we have 10/3 minus 3/3. So 7/3 or 2 1/3. So we're going to hit this x equals 5 break at 2 1/3. Okay? So we're going to hit in there. But it's not at the same value that my hole was at, right? The open circle was at 2. I'm hitting right above it. I just have to draw the circles large on the board here or it looks filled in. Okay? Would we have open or closed dots for this red chunk? One of each, right? Open on the at 0 on the left side and closed on the 5. Okay, so open circle here and closed circle here. Again, your closed circle is at 2 1/3. The blue open dot is at 2. Okay, so they aren't, that red circle is not filling the blue hole. Okay. All right, let's draw our little piece of line in here. On the far left, we're going to start at what value? Okay. And a slope of -1, I would go down 1 and right 1, right? But that's going to get me to the wrong side. Can I go up and left? Okay. All right. Should it be an open or closed dot at the end? Closed, right? X equals 0 fits there. So closed dot. All right. Does it pass a vertical line test? Now here you have to check because there are 2 places where you have vertical lines drawn in, right? And in both cases, one has a filled in dot, one has an open dot. As long as they're both not filled in, you're okay. All right. So we have a closed red dot but an open blue dot. We have a closed green dot but an open red dot. So it still passes a vertical line test. Are you doing okay with analyzing this stuff? Figuring out which equation to use? Okay, we're going to skip over to doing the range here. The range is a little more complicated again because we have pieces. It doesn't matter which green, red, or blue part uses that y value. All we care about is the y value being used? Okay, so when I look at this, I know there's no y values down on the bottom part. The lowest y value I get is -1. Is it actually used? No, it's open. So I have to be a little bigger than -1. Yes? Can I use 0? Can I use 1? Can I use 2? Yes? The red line stopped at 2 1/3. And then there's a little gap before I start with the green line. So I can use y values from just above -1 up to 2 1/3. Okay? So I can write that as y has to be a little bigger than -1, but less than or equal to 2 1/3. Okay? Then I have to leave a little break. Or I can jump up and be on this green part. What's the lowest value we have for the green? 4. And then everything above 4 is getting used by the green one. So y can be greater than or equal to 4 as well. Okay? Notice I didn't have to do anything with the blue part because it was already used by the red one. Does that make sense? Okay. All right, what shapes do we have here? All right, parabola and a line. On which side do we have the parabola? Where's our break happening? We'll get that drawn in first. Break is happening at 2. All right, so are we going left of 2 for the parabola? Okay, so y equals x squared would be over there. And then on the right side, we've got the 5x minus 6. Okay. So let's start with our parabola. This one is a basic parabola, right? We haven't moved it at all. Where's the vertex? At 0, 0. Do you guys remember when you graph parabolas, how many spaces over and up you move? You guys remember that pattern? So for a parabola, we start at 0, 0. We use 1, 1, right? And 2, 4. Yes? Okay, we go on the other side. -1, 1 and -2, 4. -3, 9. Okay, so we are graphing a parabola. Keeps going on the left side. But where we hit our break, is that an open or closed dot? Do we use our parabola function when x is 2? Yes, it equals 2 here, right? So, closed dot? All right. Our second picture, you said is a line. It starts out where? We start at -6. Okay, and we do a slope of what? So this is going to be pretty steep. We're going to go up 5 over 1. Over 1, and we landed there, right, where the green dot is. Up 5 over 1 is there. Where we, excuse me, where we hit the vertical line, open or closed? Technically it's open, but remember the green is filling it, right? So it is included, but it's included on the parabola graph, not on the linear part. Okay? And then we have a pretty steep line going up from there. Okay, so I'll get rid of my extra little dots. We've been starting on the y-axis, right, and then doing rise and run. Could I have said Since my blue line starts at 2, at x being 2 and goes, excuse me, goes to the right, could we have plugged a 2 in here? What would we get? 4? So, are we starting at the point 2, 4? So could we figure out that starting dot and then do our rise and run from there? Okay, if you want to avoid having to erase all your extra dots. All right, is it a function? Yes? All right, how about range? The lowest we get is 0. Is everything above 0 included? Yes? All right. This one has 3 parts. What's the leftmost part going to be? The top one? Okay. Then we have a chunk between -1 and 2. That's going to be just 7. Y equals 7. And then on the last chunk, the stuff to the right of 2, we have our parabola. All right. Leftmost chunk. We're going to start at -3, and we're going to do a -2 slope. But because I need it to move to the left here, I'm going to go up 2 and back 1. Okay. Where I hit my breaking line, do I include that or not? No. So I need an open circle here. The red part in between our 2 breaking lines says we just want to be at y equals 7. We're going to have a horizontal line up at 7. Okay. Open or close dots on both sides, right? We have equal signs here and here. So close dots on both. And then for our blue line, it's actually a parabola. Yes? What's happened to the parabola, to our standard parent function? It's been moved down 2. Yes? Okay, so let's picture on our y-axis, we're going to move down 2. Our normal points, we go over 1, up 1. And we, from our vertex here, we go over 2, up 1, 2, 3, 4. And we go over 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I don't know why I drew that as an open circle. Okay. So I don't want to draw this whole thing in, correct? I'm going to for now, but I'm going to erase mine, so don't draw yours in. Where I hit the green line, should that be open or closed? That should be open. All right. Does it pass a vertical line test? Okay. Can we analyze these on our own? Would we know how to do that? Okay. How about range? It looks complicated, but does the stuff I have graphed in red also is it also included with the green? Okay. Is the part that's blue also covered by what's green? So even though there's 3 chunks, I really can do my range just based off the green one. Because it says I'm going to start down here, right? And everything above that is getting used. It doesn't matter by which color. It just matters if it's being used or not. Okay? So what was this level? At -1. So we would say y has to be greater than -1. Everything else gets used. Okay. Now for the fun stuff. I'm going to give you the picture. You're going to tell me the equation. Okay? So the first thing I would analyze is I have 3 different pieces here. Okay? On the left, it looks to me like it's a parabola shape. In the middle, it looks like a nice horizontal line. And the one on the right looks like a regular positive slope line. Okay? So I'm going to have 3 chunks. I need to come up with the equations for those lines or curves, but they're fairly basic. And then I need to define the domain for that, for each of those. Okay? At what point or what chunk of my coordinate plane is used by that function. Okay? So let's start with our parabola on the left. Is it a standard parabola? In other words, over 1 up 1, over 2 up 4, over 3 up 9. So it's a basic x squared graph, right? It hasn't been stretched at all. Have we moved it at all from having its vertex at the origin? So this is my vertex here, right? So I've just moved it down 1. So I can say that x squared minus 1 is the function. And for which x values is it being used? Okay, so we have a break here, right? At x equaling 0. Since it has an open dot, I would say that function works, x squared minus 1, if x is smaller than 0. Okay? My middle chunk is applicable from 0 to 3. Okay, so the middle chunk is going to work if we're going from 0 to 3. Are the endpoints both open? Which side has the closed one? The left side, on the 0 line. So I want to close that off. I want to make it equal there. Okay, and it is important at your zeros, this one is less than, this one is equal, right? They can't both be equal. Okay. So what's the equation for this little horizontal piece? Y equals 1. All right, now here's your y here, so you don't have to put it inside. Just y equals 1. All right. Then we need something if x is greater than or equal to 3, right? For this. In order to write an equation for this line, we have to know its slope and its y-intercept. Okay? Can you tell from your grid, the one on the board here is pretty light, but can you tell from your paper copy what the rise and run are? What do you think? Barely, yes, I apologize for that. Looks like a slope of 2, up 2 over 1. Okay, so we're estimating this slope is 2. The other thing we need is the y-intercept. So we're going to have to kind of go work our way backwards to that y-axis. So if we're going to go down 2 and back 1, down 2, back 1, down 2, back 1, where are we hitting on the y-axis? Okay, so we've got b is -4. So just write your line, y equals mx plus b. So y equals 2x minus 4. Okay. Come on. Come on. There we go. All right, talk at your tables. What shapes do you see on this one?
Parabola, line, and I know. A horizontal line, and then
Okay. Far on the left, we have horizontal line. Then we have a negative sloping line. And then looks like part of a parabola. It's got a curve to it. Yes? Okay. Let's start on the left. Horizontal line at 5. Okay, so y equals 5 if x is what? This is -3 here. So if we are less than -3, we get that horizontal chunk. Okay. How about in between? We're in between -3 and 1. Open dot on the right, but closed dot on the left. Okay. What is the slope of that? We're going down 1, right 2. So slope is -1/2. This one was nice because they gave us the y-intercept at all right, so we would say -1/2 x plus 3. Okay, now for our parabola, for the parabola part, notice the difference between here and here is only 3. So this is not your vertex. Where would our vertex be? If this was our vertex at 0, 0, over 1, up 1, over 2, up 4, yes? So it's a normal parabola, vertex at the origin. We just cut off that part of our graph, right? We didn't want that part. So it's a basic x squared graph, but we want it for x's that are greater than or equal to 1. Does that make sense? Okay. Why don't you guys try 9? Help each other out. All right, let's go ahead and check this one. You had some time to work on it. How many different pieces do we have? 3. 2 lines and a parabola? Is the parabola a basic parabola? Yes. Okay, so our middle section is a basic x squared. For what values of x? Between, whoops, -3 and 3? Okay. Do we have equal signs under them or not? Yes. Okay. So we've taken care of the middle piece. Let's start with the line on the left. What is the slope? We're going up 1 over 3. Okay, so slope is 1/3. If we go up 1 over 1, 2, 3, up 1 over 1, 2, 3, we hit the y-axis at 2. So our intercept is 2. So we have 1/3 x plus 2. And that works for x's that are less than -3? Okay. How about for this one? Slope looks like -1. Okay, so we have a -1x. And if we extend it back, we're hitting at 5. And that works for x's that are greater than 3. Yes? Okay, so I am going to ask you to flip to the back side, the very back page. You see 3 graphs and you have to list the functions. I want you to do those 3 for homework, and then I have a 10-question worksheet. I want you guys, before you leave, to look at this worksheet with each other at your tables and see if there's any functions that you don't know the shapes of.